Every single time you click a link, stream a show, or send a message, this incredible invisible journey kicks off. Your data doesn't just magically appear somewhere else. It travels through this hidden world of rules, addresses, and devices. So in this explainer, we are going to pull back the curtain and follow one single piece of data on its amazing trip across the internet.
All right, so here's our game plan. We're going to start with the big problem the internet was even built to solve in the first place. Then we'll look at the universal blueprint that lets pretty much any device speak the same language. After that, we'll see how data gets all packaged up for its trip, how it finds its way through the digital highways, and finally, what happens when it gets where it's going. Let's get started.
So Section 1, the problem of isolation. Why do we even need this journey to begin with? It really all starts with one simple idea: being cut off. Think about it. Imagine a world of tiny, separate networks. Picture a single office back in the day. Sure, everyone inside that office could share files, they could share printers, and that was all fine. But what happened if you needed to work with someone in the office next door, or even across the country? Well, you were basically stuck. The whole driving force was this need to share stuff beyond your own little digital island. And the solution to that was to connect all these separate networks together to create what we call an internetwork. This is what changed everything. It took us from these self-contained islands with, limited resources to this huge connected world where information could just flow. We went from being purely local to having the potential for global communication. Now, the hero of this part of the story is the router. A router is the gadget that connects different networks, but it has another super important job. Imagine your old office network was like one giant room. If Bob shouted, "Hey, where's the printer?" everybody had to stop and listen. A router acts like a wall between different neighborhoods. Bob can shout all he wants in his local area, but the router stops that noise, that broadcast, from bothering everyone else on the entire internetwork. It keeps things organized and quiet.
Okay, so you've got devices from Apple, from Google, from Samsung, from hundreds of different companies. How in the world do you get them all to talk to each other without just complete chaos? Well, you need a shared set of rules. You need a universal blueprint for communication. And that blueprint is called the OSI model. You can honestly think of it as a treaty that creates network world peace. It takes the super complex job of network communication and breaks it down into 7 distinct, manageable layers. And the real beauty of this is that it's modular. So a company can invent a brand new, faster cable for the physical layer, and it doesn't break the whole system for everyone else.
So here they are, the 7 layers. You should really think of this as an assembly line for our data. When you send an email, for example, the process starts way up at the top with your application. Then, as the data travels down, each layer adds a new set of instructions, wrapping it up for a specific part of the journey, from making sure it's reliable at the transport layer to stamping the global address on it at the network layer, all the way down to the physical wire itself. We're going to see exactly how that wrapping works next. So how does our data actually move through all those layers? It's a process called encapsulation. And honestly, the best analogy is just dressing your data for its big trip. Putting a letter in an envelope and then putting that envelope into a bigger shipping box. It all begins right here. This is your raw data. It could be an email, a little piece of a web page, whatever your app needs to send. Right now, it's just data. It's not ready to go anywhere yet. Okay, first step is the transport layer. It's kind of like the shipping clerk. It wraps the data in a header that basically says, okay, let's make sure this gets there reliably, and it also specifies which application should get it. Like, is this for your web browser or your email client? This new package is now called a segment. And now, for maybe the most important wrapper of all. The network layer adds the global shipping address. This is the source and the destination IP addresses. This is what lets the data travel all the way across the world. Our little segment has now officially graduated to become a packet. And finally, the data link layer adds the last wrapper, which turns our packet into a frame. This contains the super local delivery instructions, the MAC addresses. Think of it this way. The IP address is the full street address of the building, but the MAC address is the name of the person at the front door. It's for that very last hop from, say, your home router to your laptop. And just like that, our data is fully dressed and ready to go. All right, our data is all packaged up and ready to hit the road, but how does it actually know where to go? Well, to navigate, it relies on 2 very different types of addresses, one for the local neighborhood streets and another for the global highways. This is a really critical distinction to get. A MAC address is a physical ID. It's burned into your device's hardware, like a serial number that never changes. It's used for local delivery, right on your immediate network. An IP address, on the other hand, is a logical address. It's like your home's street address. It can change if you move. Switches use MAC addresses for local chatter, but routers use IP addresses to navigate the entire globe.
And this quote is just a brilliant reminder that no matter how fancy all this addressing gets, the physical, fundamental stuff still matters. There's this great real-world story of a PC that had all these mysterious connection problems. After checking all the complicated software stuff, someone finally just measured the cable. Turns out it was 115 meters long, breaking the 100-meter limit for standard Ethernet. It's the perfect lesson. Always, always check the basics.
Okay, let's jump back to the transport layer for a second. Our data's journey is governed by one of two main philosophies. First, there's TCP. TCP is like sending registered mail. It's reliable, it checks to make sure every single piece arrives, and it puts them in the right order. It's perfect for things like websites and email. Then you have UDP. UDP is like sending a postcard. It's fast, it's lightweight, but there's no guarantee of delivery. This is what you want for streaming video or online gaming, where raw speed is way more important than perfect reliability. So how does a router know which part of an IP address is the neighborhood and which part is the specific house? It uses something called a subnet mask. Let's just walk through this example. The mask, that 255.255.192.0 number, it basically acts like a stencil. It tells the router which part of the IP address defines the network and which part defines the specific device. Using this logic, the router can instantly see that the device at .66 actually belongs to the network that starts at .64. And that's how it knows the packet's neighborhood, so it can send it in the right general direction. So after navigating all those local links and global routers, our packet finally arrives at its destination. The journey is almost over. And once the packet arrives, the entire journey just happens in reverse. It's kind of like unwrapping a gift. We call it decapsulation. Each layer is carefully stripped away. First the frame, then the packet, then the segment, until that original raw data is revealed and handed off to the right application on the computer. The journey is complete. So the next time you're browsing the web, or maybe your video call starts to glitch, you now know what's happening behind the curtain. There are literally millions of these tiny journeys unfolding every single second, all following these fundamental rules. So knowing this incredible hidden architecture is at work, how does it change the way you think about what's happening the next time your connection feels a little slow? You're not just a user anymore. You're an informed observer of one of the most amazing systems humanity has ever built.